MS Ramaya University of Applied Sciences.
Hi students, let us discuss field identification of igneous rocks. Rocks form an important constituent of Earth's crust. Rock is defined as a natural substance and a solid aggregate of one or more minerals. Rocks play an important role in civil engineering constructions such as roads, bridges, buildings, tunnels, dams, etc. Large part of the Earth's crust consists of granitic rocks and basaltic rocks. The continental part of the Earth's crust consists of granitic rocks and the ocean floor is basaltic in nature. There are hundreds of varieties of rock types occur in the continents classified under three broad categories. The three main categories are igneous, sedimentary, and metamorphic rocks. The three rock categories are classified based on the genesis or origin. Igneous rocks are formed due to the solidification of the molten rock called magma. As the magma cools, different minerals form crystals at slightly different times, resulting in characteristic textures. Igneous rocks are classified into intrusive and extrusive rocks. The rocks formed due to the solidification of lead magma. Solidification of magma deep inside Earth's crust results in a type of igneous rocks called intrusive igneous rocks or plutonic rocks. When the magma comes out from the interior of the Earth to the surface through the volcanic vents as lava, the resultant rock is an extrusive rock, also called volcanic rock. The important properties utilized in identification of rocks are texture, structure, and mineralogical composition. In igneous rocks, even color plays an important role in the identification. Texture of a rock refers to size, shape, and manner of arrangement of constituent mineral grains. In igneous rocks, the size of the constituent mineral grains is governed by the rate of cooling of magma or lava. The texture in igneous rocks is also related to the amount of gas trapped in the magma. Some of the igneous rocks, for example, granite and gabbro, have relatively coarse grains. The distribution of coarse or medium-sized grains in an igneous rock reflects slow cooling. Slow cooling takes place at the Earth's interior. Such an igneous rock that has cooled inside the Earth is called an intrusive rock or plutonic rock. The temperature of formation of some of the igneous rocks may be around 4000 degrees Celsius. Some of the igneous rocks, such as andesite and basalt, are very fine-grained. Such rocks reflect rapid cooling when the magma erupts as lava. The rapid cooling is due to the hot molten matter coming in contact with the atmosphere. This is an important characteristic of an extrusive or volcanic rock. Texturally, the intrusive rocks and extrusive rocks display pheneritic and aphanitic textures, where the mineral grains in a rock are recognizable with an unaided eye or with a 10 times magnifying glass. Such a rock is a phanerite or the texture is pheneritic. The rocks displaying pheneritic texture are granite, granodiorite, syenite, gabbro, dolerite, dunite, to name a few. If the grains are too fine to be recognized, such a texture is said to be aphanitic. Basalt, andesite, rhyolite are some of the examples. Porphyritic texture is a very common texture in igneous rocks in which large crystals, phenocrysts, are embedded in a fine-grained ground mass. Porphyritic texture indicates some part of magma cooling little below the Earth's surface, giving sufficient time for the large crystals to grow before erupting onto the surface to cool very quickly. The large crystals are termed phenocrysts that are set in a fine to very fine grained ground mass. Example, granite porphyry. The igneous rock is termed glassy where there is no crystallization of minerals due to very fast cooling. Some of the volcanic rocks show vesicular texture. The vesicles represent gas escape routes during solidification. When the lava is ejected with a violent eruption, the resultant rock is a fragmental or pyroclastic rock that contains fragments of assorted sizes and composition. Once the texture is identified, in the next step, the igneous rock will be categorized on the basis of their silica SiO2 content, for which the color of igneous rocks or the color index is a reflection of the rough content of silica. This enables broad classification into felsic or acidic, intermediate, mafic or basic, and ultra-basic igneous rock. The acidic igneous rocks will have SiO2 greater than 65%, intermediate 55 to 65%, mafic 45 to 55%, and ultra-mafic rock less than 45%. In general, the gradation from felsic to mafic corresponds to an increase in color index from lighter to darker shades. Accordingly, rocks are described as felsic, intermediate, mafic, and ultra-mafic in the order of decreasing silica content. In a widely accepted silica content classification scheme, rocks with more than 65% silica are called felsic. Examples: granite and rhyolite. Those with between 55 and 65% silica are intermediate. Examples: granodiorite and diorite. Those with between 45 and 55% silica are mafic. Examples: dolerite, gabbro, and basalt. And those with less than 45% are ultra-mafic. Examples: dionite and peridotite. With the basic knowledge of minerals, the mineralogy of pheneritic igneous rocks can be recognized. Granite is medium-grained containing quartz, potash feldspar, orthoclase or microcline along with biotite mica. Granodiorite shows an increase in iron and magnesium minerals such as biotite and hornblende in relation to quartz and feldspar. Gabbro and dolerite differ in their grain size and texture. Both the rocks contain plagioclase, feldspar, and pyroxene, mainly augite in varying proportions. Dolerite is in general medium-grained in relation to coarse-grained texture of a gabbro. Basalt is an aphanitic rock containing plagioclase and pyroxene of augite composition. This concludes the talk on field identification of igneous rocks.
Hi students, today we will talk about the rocks, especially the igneous rocks. Rocks in particular are of vital importance in civil engineering constructions. For example, tunnels, dams, roads, highways, bridges, etc. do require rocks. So in that way, rocks, they are very important from the civil engineering point of view. There are three categories of rocks: igneous, sedimentary, and metamorphic rocks. Today we will talk about igneous rocks. Okay, so in the earth's structure, when we talk about earth structure, the rocks are essentially confined to the crust of the earth. Okay, so there are two types of crust. One is the continental crust that consists essentially of the rocks of granitic composition. Okay, and another one, beneath the oceans, we have the rocks of the basaltic composition. However, the wide varieties of rocks within the continents, over hundreds of varieties that are present in the earth crust. So we will talk about the identification of the rocks in the field. What are igneous rocks? Igneous rocks are the rocks that are formed due to the crystallization or solidification of the molten material called as the magma. Igneous rocks are broadly classified into two types depending on the origin. The rocks that are crystallized from the magma inside the earth is called as the intrusive rock. The magma, when it comes out to surface in the form of lava flow, the resultant rock formed by the solidification of the lava is called as the extrusive rock. For example, the rock granite is an intrusive rock and the rock basalt is categorized under the extrusive rock. How are you going to identify the igneous rocks in the field? Igneous rocks are basically identified with the help of three properties. One is the texture, the color and the mineral composition. A set of 6 minerals that are called as the rock forming minerals, they comprise a large majority of the igneous rocks. Those minerals that contribute in the formation of minerals occur in different proportions. Such minerals are quartz, feldspar, this is orthoclase feldspar, this is plagioclase feldspar, this is hornblende coming under the amphibole group of minerals, this is pyroxene and this is olivine. The combination of these minerals in different proportions enable us to classify the igneous rock. Texture is a very important property that will help us in identifying the igneous rocks quickly in the field. Broadly, there are three types of textures that are displayed by igneous rocks. Some of the rock types display the mineral constituents in them that can be easily identified with unaided eye or with the help of a hand lens. Such a texture is called a phenolitic texture, where the individual mineral constituents in a rock are easily identifiable. For example, this is the pink granite. The rock pink granite consists of medium to coarse pink feldspar, and the darker grains they represent a mineral amphibole, and smaller grains which are greasy in nature and glassy, having a glassy appearance, it is quartz. Likewise, we are having, this is a rock called anathocytes, consists of relatively coarse grains of feldspar. Here, this is a gabbro. It consists basically of feldspar and the plagioclase. Plagioclase in the shades of grey and white. Likewise, minerals that can be identifiable with the naked eye or maximum with a hand lens, such rocks are categorized as phenolitic rocks. In contrast to the phenolitic textured igneous rock, there are certain categories of rocks that are too fine-grained in nature, and individual mineral constituents are very difficult to be identified even with the help of a hand lens. So, such rocks are called aphanetic igneous rocks. Generally, the rocks is a basaltic rock. These rocks come under the category of aphanetic rocks. The aphanetic rocks represent rapid cooling at the surface of the earth. When the magma comes out to surface as a lava flow, it rapidly chills or cools when exposed to atmosphere. This gives rise to the very fine grained texture, and such rocks are classified as volcanic rocks. In addition to phenolitic and aphanetic igneous rocks, there is yet another category of rocks that display a special texture called as the porphyritic texture. It is a porphyritic texture which consists essentially of very coarse and medium grained mineral grains and set in a fine grained ground mass. This combination of coarse grains embedded in a fine to medium ground mass is called as the porphyritic texture. Almost all the rock types, they sometimes crystallize with the porphyritic texture. The porphyritic texture generally occurs when the rock crystallizes just below the surface of the earth. The volcanic rocks that show aphyritic texture to a large extent also some of the important other textural characteristics. Some of the rocks are extremely fine grained and there have been no crystallization of minerals in view of a very rapid rate of cooling, and such rocks appear very glassy in nature. The rock type obsidian is an example. And some of the other rock types also show small openings here, openings that represent the escape route of the trapped gases that are present in the lava or magma. Such a texture displayed mainly by the rock types such as basalt and diorite are vesicular in nature, and they are termed as vesicular igneous rocks. When the lava erupts with a very violent explosion, the lava will be having many of the angular fragments of assorted shapes, sizes and composition, and they get solidified. Such a rock is called as a pyroclastic rock. The texture and in combination with mineralogy of the rock, of the igneous rock, especially very important from the civil engineering point of view, because they determine the compressive strength of the rock of any of the civil engineering structures. Now we will talk about the color of the igneous rock. Color of the igneous rock, or we call it as color index, is yet another important property that will help us to identify the igneous rocks into different categories in the field fairly quickly. Some of the igneous rocks are the shades of very light colored hues, or maybe slightly darker or dark or very dark in color shades. This property will help in identifying different rock types. For example, the rock types such as pegmatite, grey granite, granite and pink granite are in the light color shades, because light color shades represent a high silica content. Silica is SiO2 content in the range greater than 65%. So silica is a major constituent in the rock, in the igneous rock, and this enables us to classify the different igneous rock types. Okay, and here the next category of the rock, which has got a slightly lower SiO2 percent in relation to the dark minerals that are mainly iron, magnesium minerals. Okay, it is called as such a rock is called as the granodiorite category of rock, which has got around 55 to 65% of silica. There will be a drastic reduction in the silica content and slight increase in the darker minerals. The third category of rocks is the basic rocks. Basic rocks with SiO2, they are slightly darker in color with SiO2 content varying between 45 to 55%. There will be increase in the dark colored iron, magnesium minerals. The last category is the ultramafic category, is very dark in color, and there will be either nil or very little, about 10% of silica present in them. Such a rock is called as the ultramafic category. And these granite, granodiorite, this is rock called as the gabbro, these are pyroxenite, they all come in the category of the intrusive igneous rocks, or we call them as plutonic rocks. Whereas similar composition exists the volcanic rocks too. Okay. And basalt is the one which comes under the basic rock type category, but it is of volcanic in nature. Igneous rock mineral composition. So the color is related to the mineral composition. We have igneous rocks in the lighter color shades, darker color shades, and the very darker color shades. Now let us talk about the composition. Now we are having the set of plutonic igneous rocks, or what we call them as intrusive igneous rocks. This is the set of rock that has got a lighter color shade. Okay, and this is a rock called pegmatite that consists essentially of quartz and feldspar, large grains of feldspar. Okay, and this is a granite in two different color shades with slightly varying quartz feldspar content, along with biotite mica, as discussed before. This contains mainly tiny grains of a medium grained quartz and slightly dull looking feldspar grains and dark mica, that is a biotite mica. Similarly, this is also a granite, but seen with a light pink shade. That is because of the presence of the pink feldspar called as the orthoclase feldspar, which is potash bearing. Otherwise, the composition more or less remains the same for all these three rock types. These two rock types come under the category of intermediate igneous rock type. They are basically a granodiorite rock, but having a different grain size and varying percentage of light colored and dark colored minerals. Here this is essentially a coarse grained granodiorite with reddish brown pink feldspar, that is of orthoclase feldspar composition, along with quartz and dark colored mineral mica and hornblende. This is a granodiorite. This is also a granodiorite occurring as a very fine grained, relatively fine grained mineral constituents, having composition of tiny grains of quartz, feldspar and biotite and hornblende minerals. They come under the intermediate igneous rocks. There will be enhancement of the iron magnesium minerals, that is hornblende and biotite, in relation to quartz and feldspar. The next category of rock is the basic rock, or what we call as mafic rocks. It has got enhanced amount of the dark minerals. They are basically the pyroxenes. They are basically pyroxenes. Generally, augite is a type of pyroxene that is found in the rock called as gabbro, along with the plates of feldspar that are mainly calcic in nature. They are the plagioclase feldspar. They come under the mafic rock, igneous rock category. The last one, what you are saying, is the dark colored igneous rocks with very different grain sizes. Some are very coarse grained or medium grained, and composite essentially the pyroxenes and olivine in them, and quartz is invariably absent, or even if present, it will be less than 10%. They come under the category of ultramafic igneous rocks. Now, What we have just now described, they all come under the plutonic igneous rocks. And the same composition, similar composition exists in the volcanic rocks too. And in relation to the granodiorite composition, at our intermediate nature, we have the andesite rock, a volcanic rock, but very fine in grain, and minerals are not possible to be identified with the naked eye. However, chemical analysis helps us in identifying the SiO2 percentages. They are the intermediate igneous rocks of volcanic origin. Similarly, the basic igneous rock of volcanic origin is basalt, similar to gabbro here, and dolerite. We have the mineral composition essentially consists of, it is difficult to find out the minerals here. They are under microscope, it is possible to find out. They are the fine, tiny white specks of periodical feldspar along with the darker minerals that are basically pyroxenes in composition, or to be specific, they are augite mineral. Now, this completes the experiment on the identification of igneous rocks in the field.
At MSR UAS, we spark your imagination unlike any other.